Okay friends, so now we are looking at the term symbols which is given by this formula and the atomic term symbol or the spectroscopic term symbol which is given by this formula. Okay, and over here S is the spin angular momentum, L is the orbital angular momentum, and J is the total angular momentum, right? Now we'll see some examples. Okay, first example, suppose it's given that find the term symbol of 2p1 or say the atomic term symbol of 2p1 and 3p1. Okay, so first let us draw the orbitals for the p orbital, which has three orbitals, right? It has only one electron for 2p, and 3p also has three orbitals and one electron. Okay, we assign the ml values in the top, which goes like +1 0 and -1, +1 0 and -1. These are the ml values. And now what do we have to find in the atomic term symbol? L and S. So over here L is given by the summation of the two, summation of L, which is equal to L1 plus L2, which is nothing but 1 plus 1, which is equals to 2. And we know already that S, P, D, F, these are assigned the given L values of 0, 1, 2 and 3. So 2 will correspond to D. And now for spin, what we can do is the total range of spin values is actually from like S1 plus S2 to S1 minus S2, right? And if we do that, what we get? Half plus half to half minus half, which is equals to 1 and 0. And if they have like a bigger gap, then the only the numbers which are like bigger or lower by unit of 1 will correspond. So 2s plus 1 is equals to over here 3 and 1, right? Normally we can just do S1 plus S2 only. The reason being because we know that the maximum value of spin multiplicity is taken as the most stable, and the maximum value of L, the orbital angular momentum, is also taken as stable. That's why we just did summation. You have just done S1 plus S2, but just to show the process I showed you. And over here, so we have D and we have 3. So it can have values of 3D and 1D, right? But this is more stable, so this is actually the accepted answer. And so just before going to the next example, I'll just tell you the rules of which is more stable and which is less stable. Okay, so the rules are something like this, that the allowed values of L and of S, right? These are from -ml to ml, and these are from -s to s, right? Just what we did over here. Okay, and we take the mod values. Okay, and but the what is the most stable one? Most stable is your maximum value of s or l, right? Similarly, if we are like when j comes into the picture, what we do is the allowed values of j will also be equal to l plus s to l minus s. So this is the total range, and if it is more than half filled, then the value of j is taken as L plus S. If it is less than half filled, then the value of j is taken as L minus S. So in these cases, what we first see is, suppose we are given a term symbol and we have to look for the most stable one, and we have values of L, S and J. So first we'll see the maximum value of S in which one in the cases. Second, we see maximum value of L, and third we go for this rule, whether it's more than half filled or less than half filled. So S is given first priority, then L, and then J. Okay, now these are very easy rules to remember, and having that noted, we'll go to the next example. I'll just rub this part out. Now we go to this example of, suppose now we are given 3p1 and 3d1, right? So in 3p1 what we can do is again draw the orbitals, the ml values, and 1 over here. In 3d1 also similar things, 1 over here, and plus 2 plus 1 0 minus 1 minus 2. These are the ml values of d, right? We find out the L value is again by summation of L. So 2 plus 1, which is equals to 3, and we find out the S values. So as we just finding the most stable one, we'll just like have the addition of them only. So half plus half, which is equals to 1. Therefore 2s plus 1 will, as a spin multiplicity, is 3. And 3, if you remember, is corresponds to F. So the most stable over here is 3F. That's it. So easy. Now we come to the next one. It's a different kind of example now. V3 plus. Now V3 plus has a D2 configuration, and when you know this, you know the whole picture, right? So just draw the d orbitals as we have drawn before, right? So 1 over here, 1 over here, like electrons, and assign the ml values. And so L values, now we have a summation of L as 2 plus 1, which is equals to 3. Again it's F, and spin value we will have as half plus half, which is equals to 1, and the 2s plus 1 value will get as 3, right? Again this term symbol is nothing but 3f. Okay, so now let us come to a different form of example. Suppose is given, find the atomic term symbol of nitrogen. So nitrogen, what we know, the electronic configuration, that it has like 7 electrons, and like 1s2, 2s2, and 2p3, right? So these have no contribution, only the, like we only see for the vacant ones, or the sorry, the outermost ones, right? And not only that, if you actually look for like 1s, so it actually has like no contribution in actual, because the spin is 0, and as well as the ml value is 0, right? Because it's totally filled up. So this has no contribution, we only look for the p ones. And over here we can have the 3 orbitals, 2p3, so 1 electron, 1 electron, 1 electron, and we assign the ml values. And now it's, as we just do it before, summation of L, which will give us 0, that means corresponds to S, and the spin value, which is like half plus half plus half, right? Which is equals to 3 by 2, and therefore 2s plus 1 is equals to 4, and therefore the total of this will come as 4s, right? So we got the term symbol for nitrogen. And I'll just show you last example, which is of a, like a slightly of a different kind. And if you know this, so this atomic term symbol part will be totally over. So yeah, let us focus on this, right? D4. So we have D4, and suppose it's in low spin form, right? And so this is different, that is in low spin. And so what we have over here is D, as you know, it has 5. So this is kind of a different one, because in D complex, you know, suppose for an octahedral complex, right, you take this, and if it's low spin, what happens is it gets filled up over here only and doesn't go. If it's high spin, this electron would have gone over here, but if it's low spin, it goes over here. So like we fill up these 3 first, and again we come back over here, right? So this is plus 2 plus 1 and 0. Okay, and therefore the L value will be equal to plus 2 plus 2 plus 1 plus 0, which is equals to 5, which corresponds to H. The spin value will correspond to half minus half plus half plus half, because minus half as in because it is spread up, right? So it's equals to 1. 2s plus 1 will be equal to 3. So the term symbol over here will be equal to 3H. Okay, so this is a different kind of example which might be asked in the exam. And with this we have covered all the possible sort of types for the atomic term symbol. And in the next video we'll cover molecular term symbols.